Hey everyone, welcome back to our channel. Today we're diving into one of the most critical aspects of writing clean and readable Python code, indentation. So what exactly is indentation in Python? Why is it so important? Indentation isn't just about making your code look pretty. It's essential for defining the structure and flow of your program. Using consistent indentation helps improve readability and maintainability, making it easier for others and your future self to understand and work with your code. Have you ever tried reading code without proper indentation? It can be a real headache, right? In the previous video, we saw that one of the key rules in PEP 8 is about indentation. So what's the standard? PEP 8 recommends using 4 spaces per indentation level. Not tabs, not 2 spaces, but 4 spaces. Why 4 spaces, you ask? It strikes a balance between readability and ease of use. Plus, it ensures consistency across different editors and environments. Have you ever opened someone else's code and found it a mess of mixed spaces and tabs? Annoying, right? Why does indentation matter so much? First off, readability. Consistent indentation makes code easier to read and understand. Imagine trying to read a book without paragraphs. It would be a nightmare. The same goes for code. Proper indentation also aids maintainability, making it easier to update and fix code. And when you're collaborating with others, consistent indentation ensures that everyone can easily read and contribute to the codebase. Have you ever worked on a team where everyone had their own indentation style? Chaos, right? Let's look at some examples. Notice how the function header is at the base level with no indentation. Next, we write an if statement inside the function. We indent it with 4 spaces to indicate that it belongs to the function block. The if statement is now part of the function's block. Inside the if statement, we call the function doSomething. This line is indented with 4 additional spaces to show it belongs to the if block. Now let's add another if statement inside the first one, indented with another 4 spaces. This indicates that this if statement is nested within the first if statement. Finally, inside the nested if statement, we call another function, doSomethingElse, indented with 4 more spaces. See how clear and structured the code looks? Each block of code is indented to show its logical grouping. The outer if statement checks a condition, and if it's true, the doSomething function is called. If there's another condition inside the first one, doSomethingElse gets called. Proper indentation shows this hierarchy clearly. But what happens if you don't follow this? Yikes! This code will throw an indentation error. Python relies on proper indentation to understand your code structure. The outer if statement has inconsistent indentation levels for the following block, confusing Python about what belongs to the if statement. The inner if statement also has incorrect indentation for its block. This inconsistency makes the code hard to read and breaks its execution. Now let's see some more examples to have a better understanding of indentation and why it is important. Here we have a function definition with proper indentation. We define a function called example function. The function doesn't take any parameters and is defined using the def keyword followed by the function name and parentheses. Inside the function, we declare a variable x and set it to 10. We then have an if statement to check if x is greater than 5. If it is, it prints x is greater than 5. Otherwise, it prints x is 5 or less. Notice how the code follows the PEP 8 guideline by using 4 spaces for indentation. This consistent use of indentation makes the code more readable and easier to understand, especially as the codebase grows. Now let's see what happens with improper indentation. The code performs the same operations, but the indentation is inconsistent. The lines inside the function are indented with varying spaces instead of the recommended 4 spaces. This goes against the PEP 8 style guide and makes the code harder to read and understand. When working on larger projects or collaborating with others, this lack of proper indentation can lead to confusion and errors. Ever tried reading code like this? Frustrating, isn't it? Next, let's look at another common structure in Python, loops. Here's a properly indented example. We define a function called loopExample. Inside the function, we have a for loop that iterates over a range of 10 numbers. For each iteration, it prints the current value of I. After the loop completes, it prints done. Notice how the code inside the function and the loop uses 4 spaces for indentation adhering to the PEP 8 guidelines. This consistent indentation makes the flow of the program clear and easy to follow. Now let's see the same code with improper indentation. The code performs the same operations, but the indentation is inconsistent. The lines inside the function and the loop are indented with fewer spaces than recommended. This inconsistency makes the code harder to read and understand. Have you ever gotten lost trying to follow a loop structure like this? It's no fun. Let's move on to nested structures. In this properly indented example, the function nestedExample takes a parameter x and uses nested if and for statements. The consistent use of 4 spaces for each indentation level makes the nested structure clear and easy to follow. Now let's see the same example with improper indentation. The nested structure becomes confusing and hard to read, making it difficult to understand the logic at a glance. It's like trying to follow a conversation in a noisy room. You miss the important details. Next, let's look at functions within functions. In this properly indented example, inner function is defined within outer function, and it uses 4 spaces for indentation, making the relationship between the two functions clear. Here's the same example with improper indentation. The improper indentation makes it harder to see that inner function is nested inside outer function, reducing code readability. Have you ever had to untangle such nested functions? It's like a puzzle. Finally, let's look at class definitions. In this example, the class myClass has a properly indented init method and displayValue method. The use of 4 spaces for indentation follows PEP 8 guidelines, making the class structure clear. Now, let's see the same class with improper indentation. The methods inside the class are not clearly separated from the class definition, making the code harder to understand. Have you ever had to work with such jumbled code? It's a headache. As we've seen in these examples, proper indentation is crucial for writing clean, readable, and maintainable Python code. Following the PEP 8 guidelines of using 4 spaces per indentation level helps ensure that your code is consistent and easy to understand, whether you're working on a small project or a large code base. That's it for today. Comment below with the most common issues you face with indentation, or share your experiences with messy code. I'd love to hear your thoughts, and feel free to ask questions in the comments section. I'll plan a follow-up video to answer those questions. Thank you for watching. If you found this video helpful, please like, subscribe, and leave a comment below. Happy coding!